Alright, in example number 3, notice once again it looks like we don't have the same base. We have a 2 and we have an 8, but you can use that method to figure out how many times do you need to multiply 2 to itself to get it to become an 8. And just like the other problem, we know that we can convert 8 to 2 to the power of 3, because 2 times 2 times 2 will give you 8. So I'm going to go ahead and just rewrite this real quick so I can have the same base. So I have 2 to the power of 3. Now what looks different about this is notice that there was already an exponent here. So we are going to go ahead and write that exponent right after the 3 in parentheses. Since we converted 8 to 2 to the power of 3, this power of 3 is now going to be distributed to both of those values that were part of the exponent, to both of those terms. So make sure you put it in parentheses so you don't forget to distribute. And we'll do that in just a minute. In the meantime, I'm going to go ahead and bring down this side over here on the left. So I got my equal sign, and I have 2x to the power of 6. And now what I'm going to do is I'm going to go ahead and write this as an equation. So I have x plus 6 is equal to this whole exponent here, including the 3 that's being distributed to it. 3 times x plus 2. Now, the next thing we want to do at this point is we got to distribute this 3 right before we can solve this. So I'm going to distribute this 3 by multiplying it to x. So therefore, at this point, right, we have 3 times x. So I'm going to write that 3 times x, and that's going to give me 3x. And then I have 3 times this 2. So I have 3 times 2. And if I multiply 3 times 2, that's going to give me positive 6. Bring down my equal sign and bring down the left side of my equation. Alright, and now it's more basic. So what we want to do is move our variables to the left and move our constants to the right. So I'm going to move my variable to the left by doing the inverse operation, which is on a positive 3x, which would be to subtract 3x. And that creates 0 on the right. So now to keep this equation balanced, I'm going to subtract the 3x from the left side as well. So minus 3x. Remember that this x has a positive 1 in front of it. It's a positive x, and there's always an invisible 1 in front. And so we have 1 plus negative 3, and that'll leave us with negative 2x. Now I want to go ahead and move my constant over to the right. So it's a positive 6, so I'm going to do the opposite of adding 6, which is subtracting 6. And that zeroes out the constant value on the left. And to keep it balanced, I'm going to subtract it from the right. So we have 6 minus 6, and it leaves me with 0. For my final step, I do need to isolate the variable by dividing by the coefficient of x. That way we can get rid of it. So I'm going to divide this out by negative 2 on both sides. And then we just end up with x is equal to 0.